Hi, geometry scholars. This is Mrs. Payne. I'm going to try to explain to you what it means to solve a right triangle. Okay. In this lesson, you will learn inverse trigonometric ratios. We're also going to learn exactly what it means to solve right triangles. So the last few lessons in chapter 9, first we learned in 9.4 what a tangent ratio is. And then in 9.5, we did sine and cosine ratios. So now we're going to look at the ratios and we're going to figure out how to get the sides. So this is exactly opposite. Like when you learn to add, then you learn to subtract. Learn to multiply, then you learn to divide. If you learn to square things, then you square root them. So these inverse operations are the exact opposite. If we had the sides, we could find the ratio. But now if we have the ratio, we can find the sides. That's why they're called inverse. So I'm also going to try to show you how to use your calculator or your phone or whatever it is you're going to use to have those ratios. And without further ado, here we go. Example 1.
Determine which of the two acute angles has a cosine of 5/10. Solution. Find the cosine of each acute angle. The cosine of angle A is equal to the length of the leg adjacent to angle A divided by the length of the hypotenuse. The length of the leg adjacent to angle A is the square root of 3, and the length of the hypotenuse is 2. So, the cosine of angle A equals the square root of 3 divided by 2, which is approximately equal to 8,660 10,000ths. The cosine of angle B is equal to the length of the leg adjacent to angle B divided by the length of the hypotenuse. The length of the leg adjacent to angle B is 1, and the length of the hypotenuse is 2. So, the cosine of angle B equals 1/2, which equals 5/10. So, the acute angle that has a cosine of 5/10 is angle B.
So this means if we have the sides, we can figure it out. Now, if the measure of an acute angle is 60 degrees, then its cosine is 0.5. The converse is also true. If the cosine of an acute angle is 0.5, then the measure of the angle is 60 degrees. So in example 1, the measure of angle B must be 60 degrees because its cosine is 0.5. So this is exactly the opposite when we learned from 9.4 and 9.5. If we had the angle, we could figure out the ratio of the sides. Now, if we have the ratio of the sides, we can just do the inverse of that. So the inverse tangent looks like tan with a little -1 power. That's not actually a power, but here's how it reads. If the tangent of A equals x, where A is the angle, then the inverse tangent of x is equal to the measurement of the angle of A. So we read that little sign there, tangent with a -1 power, that means the inverse tangent of x. So it's the same also for sine and cosine. If the sine of an angle equals y, then the inverse sine of that y equals the measurement of the angle. And if the inverse, if cosine A equals z, then the inverse cosine of z equals the measurement of A. You can see right here where it says if you have these ratios, then you can go backwards and find the angle. Okay, so here's how that happens.
Let angle A, angle B, and angle C be acute angles. Use a calculator to approximate the measures of angle A, angle B, and angle C to the nearest tenth of a degree. Part A. The tangent of angle A equals 75/100. Part B. The sine of angle B equals 87/100. Part C. The cosine of angle C equals 15/100. Solution. Part A. Because the tangent of angle A equals 75 hundredths, the measure of angle A equals the inverse tangent of 75 hundredths. Using a calculator, you get the measure of angle A is approximately equal to 36 9/10 degrees. You can use the table of trigonometric ratios available at bigideasmath.com to approximate the inverse tangent of 75 hundredths to the nearest degree. Find the number closest to 75 hundredths in the tangent column and read the angle measure at the left. Part B. Because the sine of angle B equals 87 hundredths, the measure of angle B equals the inverse sine of 87 hundredths. Using a calculator, you get the measure of angle B is approximately equal to 60 5/10 degrees. Part C. Because the cosine of angle C equals 15 hundredths, the measure of angle C equals the inverse cosine of 15 hundredths. Using a calculator, you get the measure of angle C is approximately equal to 81 4/10 degrees.
So, like I said, we're going to do practice, and I'll show you how to do that. When I was, you could also look up tables. They have these ratios in the backs of books. But for now, what we're going to do is I'll just be showing you how to use your calculator. Sometimes you put in the number first, and then you press the button, and sometimes you press the button and then put the number in. It depends on what kind of calculator you have. So just be ready for that. Now, these are some examples that we'll do in our notes together. The next concept, or the second part, is to solve a right triangle. Here's what it means. To solve a right triangle means to find all unknown side lengths and angle measures. You can solve a right triangle when you know either of the following: 2 side lengths or 1 side length and the measure of 1 acute angle. And if you have either of those situations, you can figure out all 3 angles and you can figure out all 3 sides. That's what it means to solve a right triangle. That means tell me what both legs and the hypotenuse are, and both acute angles as well as the right angle. Solving a right triangle means solving for all 6 things. So we'll do an example here.
Solve the right triangle. Round decimal answers to the nearest tenth. Solution. Step 1. From the diagram, you know the lengths of the legs of the right triangle. Use the Pythagorean theorem to find the length of the hypotenuse. First, write the Pythagorean theorem, c squared equals a squared plus b squared. Substitute 3 for a and 2 for b. When you simplify, you get c squared equals 13. To solve for c, find the positive square root of each side of the equation. This gives you c equals the square root of 13. Using a calculator, you get c is approximately equal to 3 6/10. Step 2. Find the measure of angle B. Notice that the tangent of angle B equals 2/3. So, the measure of angle B equals the inverse tangent of 2/3. Using a calculator, you get the measure of angle B is approximately equal to 33 7/10 degrees. Step 3. Find the measure of angle A. Because angle A and angle B are complements, you can write the measure of angle A equals 90 degrees minus the measure of angle B. Substitute 33 7/10 degrees for the measure of angle B. So, the measure of angle A is approximately equal to 90 degrees minus 33 7/10 degrees, which equals 56 3/10 degrees. So, in triangle ABC, C is approximately equal to 3 6/10. The measure of angle B is approximately equal to 33 7/10 degrees, and the measure of angle A is approximately equal to 56 3/10 degrees. Note that in step 2, you could have also found the measure of angle A first by finding the inverse tangent of 3/2, which is approximately equal to 56 3/10 degrees.
So as long as you have two sides, it doesn't matter if you find A first and then subtract for B, or find B first and then subtract for A. Just kind of handy. Here's some more examples that we're going to be doing together under the notes, but here is just one more example.
Solve the right triangle. Round decimal answers to the nearest tenth. Solution. From the diagram, you know the length of the hypotenuse and the measure of one acute angle of the right triangle. Use trigonometric ratios to find the values of G and H. The sine of angle H is equal to the length of the opposite leg divided by the length of the hypotenuse. The measure of angle H is 25 degrees, the length of the opposite leg is H, and the length of the hypotenuse is 13. So you have the equation, the sine of 25 degrees equals H divided by 13. To solve for H, multiply each side of the equation by 13. This gives you 13 times the sine of 25 degrees equals H. Using a calculator, you get 5 5/10 is approximately equal to H. The cosine of angle H is equal to the length of the adjacent leg divided by the length of the hypotenuse. The measure of angle H is 25 degrees, the length of the adjacent leg is G, and the length of the hypotenuse is 13. So you have the equation, the cosine of 25 degrees equals G divided by 13. To solve for G, multiply each side of the equation by 13. This gives you 13 times the cosine of 25 degrees equals G. Using a calculator, you get 11 8/10 is approximately equal to G. Now find the measure of angle G. Because angle H and angle G are complements, you can write the measure of angle G equals 90 degrees minus the measure of angle H. Substitute 25 degrees for the measure of angle H. So the measure of angle G equals 90 degrees minus 25 degrees, which equals 65 degrees. So in triangle GHJ, H is approximately equal to 5 5/10, G is approximately equal to 11 8/10, and the measure of angle G equals 65 degrees.
That's called solving a right triangle. You're usually given 2 or 3 things, and you figure out the other 4 or 3 things. And that's it. So this is a real-life problem that we'll want to look at, talking about a raked stage.
Your school is building a raked stage. A raked stage slants upward from front to back to give the audience a better view. The stage will be 30 feet long from front to back with a total rise of 2 feet. You want the rake, or angle of elevation, to be 5 degrees or less for safety. Is the raked stage within your desired range? Solution. Notice that the sine of x degrees equals 2/30. Use the inverse sine ratio to find the degree measure x of the rake. So, x equals the inverse sine of 2/30. Using a calculator, you get x is approximately equal to 3 8/10. The rake is about 3 8/10 degrees, so it is within your desired range of 5 degrees or less.
Nice, right? You can actually use this in your real life. Amazing. So I believe we're ready to start our examples, your assignment, and I look forward to helping you with that. So now you know, or we're going to practice how to solve right triangles.